Hello, good afternoon. Today I discuss solid principle. Nowadays it's a very hot cake. That means each and every interviewer asks that you have a basic understanding of solid principle or not. So solid principle, it's a list of 5 principles which make easier the object orientation programming concept. So it's very help to make the application understandable, flexible and maintainable. So S stand for single responsibility principle. So in single responsibility principle, it is saying that at each and every instance or class or module is responsible for or only one reason to change. As for example, there is a user class. On that user class, let's assume there is a just first name, last name, email, and we in constructor we set the value, and after that there is a get first name, get email. So uh, these are the method is there, and with addition, if we keep on another method, user logged in activity, what we are doing on that method, which user logged in which particular time, we store by using the file, the put content. That means we write the information in a file, that which user logged in particular which time, the login activity we stored in a file. So that method also in the user class we keep user log activity. So it is not satisfy the first principle, that is single responsibility, as because user for user, the get first name, get email, that is meaningful with user model if this present. But login activity, for that we should create another class. Why? As because let's assume that in future we have to instead of writing in a file the user logging activity, if we think that no, we have to keep all those information, or instead of file we store in a db. So on that time this class we have to change with particular this method. Let's assume this application is a big application, and on that case the other controller who use this particular instance, this object, each and every place we have to change these things. But if we instead of that, if it is a logger class, and on that logger class, as if we store this, then we don't need to touch the user class. So we should design in this way. So single responsibility principle ensure these things. The second thing is the open close principle. So open for extension but close for modification. So it ensures that when we are writing any class, on that time we ensure that if require in any changes, then we can extend the class, but not modify the existing class. The same problem we are facing, as because if we modify the main class, then each and every controller or the other resource who use this method, or there is a chance of broken. And it's very time taking for testing the entire site, and when the problem arises. But instead of that, we if we extend these things, then on that case, as the particular case, we particular thing we can change. So this is the best approach. I am just giving one example. Let's assume there is a class, say for example payment process class, and on that payment process class there is a method process. On that process currently there is a two payment process. If payment process is equal to say for example PayPal, and then we do some operation, PayPal payment, we integrate, and if it is a credit card, else then we have to do some operation. So the in this way current structure. But in future there is a requirement, I have to integrate the Google Pay, Apple Pay or Phone Pay. So on that time we have to add another if else condition, and there is a huge chance to break the entire application due to these changes, and testing is very difficult. And so what is the better approach? If we just design in such a way, it's a just simple, we do in one thing, that it's more flexible. Just we do that one interface I am creating, that is a payment interface, and after that on payment interface there is a method, abstract method, that is process. After that, let's assume we just implement a class, credit card payment class, and we just implement this interface, payment interface. After that, another class, let's assume the class name is the for PayPal, PayPal payment, and also implement and the same interface. So any controller easily he can use the interface as, and by using this it's very consistent. But in future also any payment, Google Pay, Apple Pay, we just implement the main interface, and after that easily we pass this is and we get the we can, that means anytime we extend and we can and achieve these things, and it's more flexible way. So this approach is good approach. And the third is risk of substitution principle. In this principle it is saying that uh, that uh, risk of substitution principle, subtype should not be substitutable for base class. That means let's assume there is a class bird, and one method is fly. It's a abstract class, let's assume abstract class bird, and there is a fly. So fly abstract method. So when a class, let's assume the penguin, class penguin, just extend this abstract class, that means bird. On that time, flying method is not applicable for penguin, as because penguin is not flying. So we have to give some throw error. So it's for each and every class, it's not easy to develop. But in this case, if we design the class in generic way, that what we are doing, we just simply create a class, abstract class, and that is bird. Instead of fly, move. We the class name, abstract class name is move. So it's for penguin, it's running. For other bird, for crow or parrot, it's is flying. So it's satisfy all the condition. This is called risk of substitution principle. And the third one, I think fourth one is in interface segregation principle. In this principle, what is it's telling that interface segregation principle, clients should not be forced to implement interface which he is not using. That means let's assume one class of one interface as workable class, and human worker, and there is a method, let's assume eating, sleeping, and one public method eat, one public method sleep, and another public method is working. So when this interface implement by human worker, for that case it's fine. Human worker implement the that means eating. Human worker implement the method sleeping when implement the interface. But for the robot worker, he not eating. Robot is not eating. Robot is not sleeping. So for robot is meaningless. So in this case, interface segregation principle saying that the necessary things for robot, this interface method is meaningless. So we design in such a way, we just segregate the main interface into, break into three different interface: workable interface, eatable interface, and sleepable interface. So after that, when we implement this interface for the workable class, human worker class, we just implement these three interface at a time. But for our the robot worker, we just need to implement the necessary things, that means workable interface. So in this way it's condition. This is the interface segregation principle. And the last one is dependency inversion principle. So in this principle, it is saying that higher order module should not be depend on lower order module. Both are dependent on the abstraction. So let's assume there is a class as db connect, and on that db connect, db connect class, suppose there is there one try to what happened, and we hard coded this MySQL connect in one class. Through constructor we implement, and after that by using connect we insert the data. This is the class structure. In future, if I try to change in PostgreSQL SQL Server, it's not possible. So instead of that, we generalized it. We just create a payment connection interface, and after that on the DB interface, and on that connect one method. After that, each and every, suppose for MySQL it is implemented the same connection interface as, and for that he is implementing this interface. For PostgreSQL, similar way implementing this is interface. So it's generic. In future, many more DB connection we can easily. For that we don't, it's hard coded. So this is the dependency inversion. So we just inject the in controller. So it's very easier. So I think it's I able to understand. Thank you so much. Bye bye.